So you're back for more. We need more practice with these, right? Let's do it. First, we write our augmented matrix. 2, 1, 4, -3, -1, -2. That's our augmented matrix. Vertical bar to represent the equal sign, constants on the right. If your equations are not written in this standard form where x and y are both on the left side, you need to rewrite them that way. Here, we want to first get a 1 in the top left corner. We get the 1 by multiplying that row by the reciprocal of what is there, as long as it's a reasonable operation. Here, that would be 1/2 of row 1, putting it in the row 1 spot. That means I am not changing row 2 at all. So I'm going to leave, I'm just going to copy that over. I don't want to risk changing it in some way that I shouldn't, so I'm just going to copy it over. 1/2 of row 1 means each of these numbers get multiplied by 1/2. That gives me 1, 1/2, and 2. I do have a fraction there, but I can deal with it. It's not a terrible fraction. Then I want to get the 0 in the bottom left corner. I work through the first column to get it exactly the way I want. Pause the video and try to write down what you think the row operation would be to get a 0 in that spot where the -3 is. The correct row operation would be to take the first row and multiply it by 3, the opposite of the -3 that we have, and add it to row 2 and put that in row 2. We multiply the row with the 1 in it by the opposite of what we're trying to get rid of and add them together, because then you will always have opposite numbers added together to give you 0. I am not changing the first row, so leave it. 3 times row 1, and if you need to write these, do so. I'll grab another color. This spot, 3, you'll be able to, as you practice these more, you'll be able to do these sort of in your head. I use my fingers a lot. I know you can't see that in this video, so I'm trying to do it with the pointer, but I use my fingers a lot to say 3 times row 1, and I point to the 1, plus row 2 is -3. And I'm literally just following this pattern that is right there, but replacing it with the appropriate numbers for that column. That gives me the 0 I need. This spot is going to have me do 3 times the row 1 entry is 1/2, plus the row 2 entry is -1. That's 3/2 minus 2/2, right? 1 is 2/2. That's going to give me 1/2. Then I need to do the same thing for this spot. I'm going to come out this way. 3 times the row 1 entry. I'm literally pointing to this 2 up here, plus -2, the row 2 entry. 3 times row 1 plus row 2. That's 6 minus 2 is 4. I have my first column exactly the way I want it. Yay, right? Now I move to the second column. I want, move this stuff over here, just gonna separate it off. I want a 1 in this spot in the bottom row. Get the 1 first, then work on any zeros that you need. I'm going to do 2 times row 2 and put it in row 2. Leaving the first row alone, 2 times 0 is 0. 2 times 1/2, hey, that gets me the 1 I'm looking for. 2 times 4 is 8. Next, last thing I need is a 0 in the place of this 1/2. Meaning I'm not going to change my bottom row. I definitely don't want to change that bottom row. That tells me y equals 8. I want the top row to have a 0 here so that I can get x equals a number. I do that by multiplying the bottom row, where that 1 is, by the opposite, by negative 1/2, and adding them together, putting it in row 1. Let's do it for the first column. Negative 1/2 times row 2, we're looking here. Negative 1/2 times 0, 0 plus 1. I keep my 1. Yay, that's what I want. That should always happen if you set your rule correctly. The first column shouldn't change when you're working on the second column. For the second column, we do negative 1/2 times this 1. Let's see. That's negative 1/2 plus 1/2 is 0. Maybe I should write these so you can see where these come from. This comes from negative 1/2 times the row 2 entry is 1 plus the row 1 entry is 1/2. And this one came from negative 1/2 times 0 plus the row 1 entry was 1. This guy here is going to be negative 1/2 times the row 2 entry. I'm always referring back to my rule here. That's 8 plus row 1 is 2. Negative 1/2 times 8 is negative 4 plus 2 is negative 2. That tells me x equals negative 2 and y equals 8. Or, as an ordered pair, negative 2, 8, when we convert back from the augmented matrix to our solution. You can always go back up here and check in the system you were given. And if you do that, you are going to get this solution. You have to check it out and test it, but you will get this solution. If you don't, you did something wrong in your row operations. Okay, we're stepping it up to 3 variables. The process is still the same. We write our augmented matrix. 1, negative 1, 2, negative 3, 1, 2, 3, 4, 2, negative 1, negative 1, negative 3. Good news is we already have a 1 in the top left corner, so we can just leave that. The next step would be to get a 0 in place of this 1 and in place of this 2. Let's do those one at a time for now. You can technically combine these into one step, but I'm not going to, just so we don't confuse us. We're going to work through more examples of this, and I might step up the speed a little bit going forward. The way I'm going to get a 0 here would be to do row 2 minus row 1 and put that in place of row 2. I don't want to change row 1 because that's got my 1 that I want. Row 2 minus row 1 is the same idea of multiplying this. That's the same as negative 1 times row 1 plus row 2, right? So it's the same idea of multiplying this by the opposite of what you have here and adding them together. It's just a little easier to see row 2 minus row 1. So I'm going to do 1 minus 1 is 0. 2 minus negative 1 is 3. 3 minus 2 is 1. 4 minus -3 is 7. Let's copy this guy over because we are only changing row 2 at the moment. Next, I want to change row 3, right? I want to get a 0 where that 2 is in row 3. So we are copying the first 2 rows over so that we don't do something silly like change them. We don't want to change those. Opposite of the number I'm trying to get rid of times the row with the 1 in it, which in this case is row 1. And we want to add row 3 and put that in row 3. If you need to write your steps, do it, or your calculations, I mean. -2 times row 1 is 1, plus row 3 is 2. That will give me a 0 here. -2 times the 1 plus the 2. Next step, -2 times the -1. You're always looking to the matrix above. Plus the row 3 entry is plus -1. That's 2 minus 1, or 1. This spot, I'm going to do -2 times row 1 entry is 2 plus -1. That is -4 minus 1, or -5. One more spot here. -2 times row 1 is -3, plus the row 3 entry is -3. 6 minus 3 is 3. Okay, I have my first column correct. Yay, that is good. Next, as I move over to the second column, I want a 1 where that 3 is. Typically, we would multiply row 2 by 1/3, but that is going to create some yucky fractions. 7/3, I do not want to deal with that. Remember, one of my row operations allowed me to switch 2 rows. So I'm going to switch row 2 and row 3. So I want to make sure we don't get too procedural in that when you want a 1, you always multiply by the reciprocal. Do what makes sense so that your numbers are a little bit easier to work with. I'm going to switch row 2 and row 3. 3, 1, 7. Okay. Now I have the 1 that I need. I'm going to use it to get a 0 here and where that 3 is, where the -1 is and where the 3 is. Notice row 1 and row 2 already have opposites on that column, that variable, which is y, the y variable. So we can just add row 1 and row 2 and put it in row 1. I want to get a 0 here. So I'm going to copy this guy over. I am not changing that one. In this column, that is the way I want it. When I add 1 plus 0, I get 1. -1 plus 1, I get 0. 2 plus -5, I get -3. -3 plus 3, I get 0. At the same time, I'm going to change row 3. So I'm going to do something and put it in row 3. I can do that at the same time as long as they're independent operations here. I'm not using row 3 in any way to get this calculation, so I can do it here. Opposite of what's in that position, the 3, times the row where the 1 is. So that 1 is in row 2, and add row 3 to it. The beauty of this is it still leaves a 0 in that first position. Negative 3 times 0 plus 0, still 0. For the second column, negative 3 times 1 plus 3 is 0. Negative 3 times negative 5 is 15, plus 1 is 16. Negative 3 times 3 is negative 9, plus 7 will be negative 2. We got our second column looking good. Move to the third column. We want a 1 where this 16 is. Unfortunately, there's not a good way to do it. You can't use the above columns without changing these zeros. So we have to do 1/16 times row 3 and put it in row 3. And that is the only operation I want to do here, because to get rid of this 3 and negative 5, I need the 1 in row 3. Negative 2 over 16, that's a nice round number of negative 1/8. This is going to have a pretty solution. I am going to come up, let me do this. Oh no, I have more space down here, don't I? Okay. I was thinking I was out of space. I want a 0 here and here where the negative 3 and the negative 5 are. That means I'm going to get zeros, I do the opposite of what's there times the row with the 1 in it. Okay, I am not changing that bottom row. I like it how it is. It gives me the solution for what z is. Z equals negative 1/8. I am going to change both the first and second row. 3 times row 3. 3 times 0 plus row 1 gives me a 1 here. 3 times 0 plus 0 gives me a 1. Woohoo! I didn't change anything in the first columns of this equation. 3 times 1 plus negative 3. So that's 3 plus negative 3 is 0. 3 times negative 1/8 is negative 3/8 plus 0. Now I have what x is. X is negative 3/8. Let's do the same thing for row 2 to get rid of the negative 5. 5 times row 3, 5 times the 1 plus the negative 5 will give me 0. All right, 5 times 0 plus 0 is 0. 5 times 0 plus 1 is 1. 5 times 1 plus negative 5 is 0. This calculation that's going to go here, I'm actually going to write it just to make sure I don't mess up my fractions here. 5 times negative 1/8 plus 3 is going to be negative 5/8 plus, I'm going to rewrite 3 as 24/8. So that is 19/8. Got to get a common denominator to add those. And now I can read right off. X equals negative 3/8, y equals 19/8, z equals negative 1/8. Or if you prefer an ordered pair, or ordered triple in this case, you have your solution in either format. Okay, that's it. Let's look at this application. you know what? We're at 20 minutes in this video. I'm going to stop. We'll do the application in a separate video. Give your brain a little break here too.